Hello everyone. So this is the concept on real analysis. This video precisely conveys us the notion of the convergence, uniform convergence and pointwise convergence. So in this class we try to understand what exactly the convergence is. And then we think about what is an pointwise convergence. Then we move on to the notion of uniform convergence. So, if we want to think about this convergence or pointwise convergence, first of all we want a sequence. What is a sequence? Sequence means, for example, if you are, let me say, you are going in a park, or else if you are traveling on a road, somewhere you will get the tree number, like it may start like 1, 2, 3, 4, 5, or else somewhere it may start with 121, 122, 123, 124, 125. So it's in a sequence, right? If it's arranged in the other order, for example, if it is a road, so it may be 121 and it may be 122, 123, and here I have 124. So you will get only odd numbers here and you will get even numbers here. So it's a sequence. So the mathematical definition for this is, consider a function from natural number to, if you are getting a real number, it's a real sequence. Or if you are considering a complex number, it's a complex sequence. For example, f of n is equals to n square. So this is if I plug in n, natural number. If I plug in 1, it is 1. If I plug in 2, it is 4. If I plug in 3, it is 9. So for the given input, 1 is going to 1, 2 is going to 4, 3 is going to 9. So this and all are real numbers. So it's a real sequence. Likewise, you can think about the complex sequence also. Is it clear? So, however, we restrict ourselves to real analysis right now. So we consider only this. We will consider this case later. So a sequence is a function from natural number to real number. That should be recorded in your mind. Then when we say that a sequence is convergent, we will discuss these things in detail, but for the time being, I want what exactly this convergence is all about. So, let me say, I will consider an example. Sequences are usually denoted by the symbol xn or an. So, I will consider a sequence xn and to be 1 by n, where n is a natural number. So, how does this will behave? What is the nature of this sequence? See, put n is equals to 1. What is x1? It is 1. x2, it is 1 by 2. x3, it is 1 by 3. x4, it is 1 by 4. See, its value is 1, its value is 0.5, its value is 0.33, its value is 0.25. If I ask you, if you go likewise infinitely, then where you will approach. See, whether it is decreasing, then you may say, sir, it goes to 0. As n tends to infinity, this will go to 0. In the sense what? You can guess what happens after one stage. See, I have, if I plot it likewise, so this is, let me say, 0 and this is the 1. And for this is the place for x1. Am I right? And for x2, this is the place. x3 somewhere here 1 by 3. x4 is somewhere here 0.5. It goes on and on and on and on and on. Somewhere it will go to 0. I am telling it approaches 0. It won't be exactly equals to 0. It will be near to 0. Is it clear? So in that sense, it will go to 0. That is called the limit of that sequence. So stand at that 0. Let me zoom this. Okay. So it will look like this. This is 0 and this is 0.0001, let me say. So this much space is there if I zoom this. So the terms of the sequence, how does that will look like? The terms of the sequence will be somewhere. It will be very near to this. Okay. So in the sense, stand at 0 and try to draw a circle, or else consider an ball, we say, a distance called epsilon radius. So stand at 0 and take some epsilon. Then you can capture all the elements. You can capture all the elements of the sequence, but finitely many are left out. Like 1 is left out, 1 by 2 is left out, 1 by 3 is left out, 1 by 4 is left out. But whereas if you just stand at 0, after finite terms, all the other terms will be captured by that ball what you had drawn. That is called the notion of convergence. Is it clear? For example, you take epsilon equals to 0.001 radius. You stand at 0 and try to draw 0.001 radius. So it's an epsilon ball. You are at 0 and you are writing 0.001 radius. Every fellows can be captured by this ball. That's called convergence. Is it clear? Every member will be trapped in this ball. So that is exactly the convergence of the sequence. So let me put them in a mathematical way. Convergence of the sequence. Convergence in the sense, let me say xn is a sequence. It converges to L, a limit L, if for given any positive real number, that is this epsilon, the radius, there exists a stage, let me say n naught. Stage in the sense it's a natural number. There exists a stage n naught, which is nothing but a natural number, such that the distance between xn and L can be made however small you want. And this will work for not for all n. This won't work for all n. For some n, but see here, that's what I am telling. If you stand at 0 and if you want this epsilon radius of 0.001, you will be here. If you are drawing a radius here, somewhere you will be trapping all those elements. But if you had constructed the same 0.001 radius, whether x1 is there? No. Whether x2 is there? No. Because your radius is very small. It's somewhere here, a tiny ball. It doesn't contain x1, it doesn't contain x2. If it contains all those elements, I would have been written for all n. Is it clear? This will work for a stage. And that stage is this n naught. The stage is that n naught. After that stage, every fellows will be trapped in your desired ball or else desired radius. That is called the notion of the sequence. Is the notion of the sequence is clear? Convergence is clear? Then we move on to pointwise convergence. We will discuss these things in detail in the next uploading videos. But as of now, I want to discuss mainly what is the pointwise convergence and uniform convergence. See, first we need to understand what exactly pointwise convergence. As we know the notion of convergence, we just want what is this pointwise convergence. To understand this all at once, I will consider one example, then we move on to the formal definition, mathematical definition of this pointwise convergence. See, here let me consider Fn is a sequence. It's a sequence of functions. It's a sequence of functions. That means F1 is one sequence, F2 is a function, F1 is a function, F3 is a function. All are functions. Then the domain should be defined for that. For example, let me say Fn of x is x to the power n, where the inputs are allowed to take from 0 to 1. That is called the domain of the function. If you look to the previous video, I had explained this. So this is the domain of the function f df. Now, what will happen to this? What is the nature of this sequence? See, for this, I just try to think about in this way. So the domain is closed interval 0 to 1. So I will plug 0 first. Then what will happen to F1, F2, F3, F4, F5? Let me check. So what is F1 at 0? So 0 to the power 1, it is 0. For F2, 0 square, it is 0. For F3, 0 cube, it is 0. So every member are nothing but 0 only for this. It's a null sequence. Then I will consider some other point here. Let me say half. So what will happen if I say x is equals to half? So it is 1 by 2. Plug in x equals to 1 by 2, that's all. 1 by 2 whole square. Then 1 by 2 whole cube. 1 by 2 whole to the power 4 goes on and on. So but what is the value of this? It is 1 by 4, 1 by 8, 1 by 16. So it's decreasing, right? Somewhere it will go to, after one stage you will say, sir, this will converge to 0. I will get 0 only. Approximately, not I am saying exactly equals to 0. It will approach to 0. Similarly, if I consider 1 by 3, what will happen to this? 1 by 3. 1 by 3 square means 1 by 9. 1 by 3 cube it is 27. 1 by 3 to the power 4 it is 81. So it goes on and on. Where it will goes? So it's also decreasing. So this will go to, after one stage you can say this also will approach 0, sir. Are you getting my point? Let me say the first stage, what else you had here for the first sequence? It is n1, the stage. That is a natural number. Here you can find one more step. Let me say it is n2. Here you may find a different step or else different stage. Let me say it is n3. So n3 is a stage associated with this. n2 is a stage associated with this. n1 is a stage associated with this. Is it clear? Similarly, let me say this is n0. So for every member, 1 by 3 is over, 1 by 4 you take, 1 by 5 you take, it will go to 0 only. But you plug in 1. What will happen now? If I plug in 1, so for n is equals to 1, it is 1. For n is equals to 2, it is 1. For n is equals to 3, it is 1. So it will converge to 1 only. Is it clear? So here what else it is happening here is, every member you take, for 0 you are getting 0, for 1 you are getting 1, for the remaining fellows you are getting 0. That means for every point in the domain, the sequence is convergent, isn't it? Here also the sequence is convergent. You can find a stage and you can trap them within that ball. This is also convergent. This is also convergent. This is also convergent. So every member is convergent. That means to what it will converge? Fn converges to what? Fn converges to a function. Can you define this function? For x equals to 0, what was the value? What it will converge? It will converge to 0. For x is equals to 1 by 2, to what it was converging? It was converging to 0. For x is equals to somewhere 1 by 4, still it is 0. 1 by 3, still it is 0. Isn't it? So for any value it will be 0. But if you choose a point here, this is 1. That means you can trace out where they are going. So this f is precisely 0 if x is lying between 0 to 1, but 1 if x is exactly equals to 1. Is it clear? So a sequence converges to a function. It is converging to a function pointwise. For every given point in the domain, it converges. That is called pointwise convergence. Is the definition is clear? Why it is pointwise convergence? So now we move on to the mathematical definition of this pointwise convergence. Try to understand this. Pointwise convergence. So let E be the domain of F, be a subset of R. Here particularly it is 0, 1, closed interval 0, 1. We say the sequence Fn converges to F pointwise. A sequence of functions Fn converges to F pointwise if for all x in that domain of the function f, there exists a stage such that you give me any epsilon, which is a positive real number, I can trap them within that ball. And this will work for all n greater than or equals to n naught. Is it clear? If for all x, this should work. See, for every x, I can find the convergence. Give me any number here in the domain. I can find where it will converge. So this is the meaning of pointwise convergence. Then what is uniform convergence? The definition is, you need to understand the definition itself defines how to define them. Because those and all are derived from English. You need to understand what is the pointwise, what is uniform. See, what is pointwise then? As we observed, in pointwise we say this: given any point in the domain of F, we can find a stage n naught. You throw me any epsilon, that is, for given any epsilon positive, I can find, if you are throwing me an epsilon, sir, I will give you an epsilon, try to find that ball. And I can find a stage n naught. If you give me an epsilon corresponding to that, I can find a stage n naught, such that Fn of x minus f of x, that is the difference between them, is negligibly small. And this will work for all n. So this is the definition for pointwise. But what is the other thing is, what made us to think about uniform convergence? Here what was the idea? Given any x in the domain of F, we need to find a stage. We are finding one particular stage, and that stage used to differ. But the next question, what else led us to uniform convergence, is whether it is possible to find a stage which works for every x. Is there instead of finding for each member, if we are finding a stage, see here, we used to find a stage n0, n1, n2 likewise. Now the question is, I don't want likewise, I just want one member from the natural number. Let me say n, or else a natural number n, which works for every number. You take any member in this domain, this number should work. whether it's possible. That is called uniform convergence. That is, that n is uniform. No need to bother about anything. Just consider that stage will work. That is the uniform convergence. Is it clear? So let me put them in the mathematical way. What is the uniform convergence? Same definition. Let E be a subset of R, which is nothing but domain of the function f. And we say the sequence of functions fn converges to f uniformly if there exists a stage. See, I am writing there exists one stage such that for any positive epsilon there exists a stage such that give me any positive epsilon, we have fn of x minus f of x is less than that epsilon for all n greater than or equals to n naught, and this will work for every member. Try to understand the difference. See, in the pointwise convergence we had written this for all x in x here. If I had written it here, it's pointwise. Grammar matters. If you are writing the definition, see, if you started with for all x in x there exists a stage n naught, it's an pointwise convergence. But if you don't write here, if you write at the last, that means it works for every x. But here you are concentrating in the pointwise convergence. In the pointwise convergence you are concentrating given any point, that means for all x. First you consider the point, then you go to the convergence. But here you think about the convergence, then you consider any point. It's okay, no matter. Any point you give me. Is it clear? So pointwise means for every x there is a stage n naught. Pointwise means for every x there exists a stage n naught. Uniform means there is a stage n naught which works for every x. Is it clear? And one more thing is, if I have the uniform convergence, it is always pointwise convergence. If I have the uniform convergence, it is always a pointwise convergence. But the pointwise does not imply me uniform, need not be. We will discuss these things in detail in the next upcoming videos. Is it clear? There are some tests to show this uniform convergence. We will look at those things in detail in the next class. You can think about MN test for the sequence, and you can work out some problems, and later on we can move on to what is the relation between uniform convergence and continuity, uniform convergence and differentiability, and uniform convergence and integrability, whether they are related. We already know differentiation, integration, so whether and continuity. If we know these three things, whether is there any role played by this uniform convergence. However, I'd like to summarize what else we studied in this today's class. We studied what is the convergence, and we studied the notion of pointwise convergence, and we studied the notion of uniform convergence. But the questions that they will ask will be more from uniform convergence because it has more richer properties. And pointwise convergence they will ask in convergence also, but these you can answer. But the challenging thing is in the uniform convergence. We will sort out some problems, we will discuss some problems, then we can understand what exactly where we are leading to. Is it clear? I will try to upload the MN test and the remaining concepts in the next upcoming session. Thank you for watching. Have a good day.